Let's go ahead and solve homework exercise number 19 from section 10.2. It states that a 19-foot ladder is placed against a vertical wall of a building. So here we have our building and our ladder right here. Okay, and the ladder is 19 feet. The bottom of the ladder is standing on the level ground. There's the ground, 16 feet from the base of the building. So from here, so this side here is 16 feet. How high up the wall does the ladder reach? So the height we're trying to find right there. Now the building and the ground make a right angle. So this is a right angle here. H and 16 are the two sides, and 19, the ladder, is opposite the right angle, so that's the hypotenuse. So we can use the Pythagorean theorem to solve for the height, how far the ladder reaches, which is, we'll call h. So again, the hypotenuse is 19, so it's 19 squared is equal to h squared plus the other side squared is 16 squared. Okay, so again, we'll go ahead and do 19 squared and 16 squared on our calculator. So we'll have 19 squared is 361 and 16 squared, I believe, is 256. Okay, so now we have, again, the ladder. Here's the building, the height. The ladder is 19 feet, and from the ground to the base of the building is 16. So again, 19 squared equals, I call it, well, whatever, h or a, it doesn't matter which variable. H for height is equal to the height squared plus 16 squared. 19 squared we did on our calculator, 361 equals h squared plus 16 squared is 256. Subtract 256 from both sides, so that then we just get h squared. When we do that, we get 105. So if we take the square root of both sides, square root of 105 is equal to h. Square root of h squared is h, is what we want to solve. So again, we round to the nearest, 100th, be careful. So that's 2 decimals. So we'll use our calculator, doing the second and the x squared key to get the radical sign, and then we'll put in our 105 and round to the nearest 100th, which is 2 decimal places. Okay? So second x squared, 105, is 10.2469. 10.2469, so there is a 6 in the third. There's 4 is the hundredths, a 6 is in the thousands, so we're going to add 1, and we'll round off to 10.25. And of course the units are feet. Everything is given in feet. So 10.25 is how high the ladder reaches. And the units are in feet. Very good. Let's look at problem number 20. A flagpole has a height of 20 yards. Okay, so the flagpole has a height of 20 yards up. It will be supported by 3 cables, each of which is attached to the flagpole at a point 4 yards below the top of the flagpole. So here's a cable, and this is 4 yards from the top of the I'm sorry. Whoa, let's be careful here. A flagpole has a height of 20 yards. Each cable is attached to the flagpole at a point 4 yards below the top. Okay, so the whole flag is 20 below, so let's draw it one more time. So the entire flag, be careful, is 20, okay, and the wire is connected 4 yards below the top. So this is 20, so then right here would be 16 yards because the entire flagpole is 20, but we're connecting it 4 yards from the top, so 20 minus 4 would leave us with 16 as the height. Actually, the 16 to 20 yards is the perpendicular, the flagpole. Okay, so be careful. That's a little bit tricky. Now, at a point 4 yards, 4 below the top and attached to the ground at a point that is 12 yards from the base. So now here on the ground is 12 yards from the base, okay? And then it says find the total number of yards that cables will be required. So here's one cable, and remember we have 3 cables, so when we just do one cable, they're all the same. Now again, in this case, the cable is opposite the right angle. The flag and the ground form the right angle. So the hypotenuse is the flag. So we're going to set it up. And again, the entire flagpole is 20, but it's 4 yards from the top. So that means the wire goes up to 16 yards. That's how I got 16, because it's 4 yards from the top. So now if we set up the Pythagorean theorem, the wire is the hypotenuse opposite the right angle, so it's x squared equals 16 squared plus 12 squared. 16 squared I know is 256. 12 times 12 is 144. So when we add these two together, 256 and 144 gives us exactly 400. Okay, and then I'm going to take the square root of both sides, and the square root of 400 is actually 20. Again, you can use your calculator, but 20 times 20 is 400, so I know I just did that in my head. Again, you could do the second, the x squared, and then 400. 20. Now notice, each wire is 20. There are three cables, so each one is 20. 20 times 3, of course, will give us a total of 60 yards. Everything is given in yards because there are 3 cables. So we got to multiply the length of one cable by 3, and we get a total of 60 yards. All right, very good. The answer came out to a whole number, so we didn't need to worry about any rounding off. Okay, let's look at question number 21. A rectangular garden bed measures 4 feet by 3 feet. So we have a rectangle 3 by 4. A water faucet is located at one corner of the garden bed. A hose will be connected to the water faucet, and the hose must be long enough to reach the opposite corner. So here's the faucet, and the hose goes along here, which would really be the diagonal. Opposite corner of the garden bed when stretched straight, find the required length of the hose. So the hose is right there. The length of the hose is x. Now notice, rectangles have both widths and lengths are equal. So this is 3 and this is 4. So either one, if you look at this triangle right here, we have the length is 4, the width is 3, and then the hose goes across, which again, there's right angles in a rectangle. So the right angle here, so again, the hose, it's a right triangle, the hose is opposite the right angle, so we can use the Pythagorean theorem to find the length of the hose. Again, c squared equals a squared plus b squared. C is the hypotenuse opposite this right angle, which is the length of the hose. We called x. So x squared is equal to the one side squared, 4 squared, plus the other side squared, 3 squared. So 4 squared is 16. 3 squared, 3 times 3 is 9. So x squared is equal to 25. Take the square root of both sides and get x as the square root of 25, which we know it's a perfect square, which is equal to 5. So the hypotenuse of this right triangle is the diagonal, which is the length of the hose. So it's going to go ahead and be 5 feet using the Pythagorean theorem, because we ended up with a right triangle. And the units are in feet. All right, very good. We're going to stop this session here. at problem homework exercise number 21. If you have any questions, send me an email or call me at send me an email at tswers.hodges@hodges.edu or call me at 239-938-7805. Thank you.